Good morning. It is virtual day 27, April 27th. More circles. So day 6, this is arc measurement and properties of chords. So we are starting off by finding the measure of each arc of the circle. The central angle, so that is an angle whose vertex is at the center, is congruent to the arc. So the measure of the central angle is congruent to the measure of the arc. Let me make a note of that over here. Central angle. Angle whose vertex is the center of the circle is congruent to the arc. So the arc that it creates, the measure of the arc is the same as the measure of the central angle. So arc MN there, this is a central angle because this is the center. So that is congruent to this arc in. So that's 100 degrees. Arc MPN is the arc that goes this way. Arc MPN. So because this is 100, that's going to be 360 because a whole circle is 360 minus 100, which is 260 degrees. PMN, this is a chord that goes through the center of the circle. So this is a diameter. A diameter subtends half the circle. So this PMN is going to be half of 360, which is 180 because that creates a line. And then PM, because this whole thing is 180, then PM has to be 80 degrees. 180 minus 100 gives us that 80 degrees. Example 2, more finding measures of the arcs. Assuming that is the center, which is what we're told to assume here. Arc GE, G to E. So if it doesn't have a letter in between, then it's assuming the shortest distance from G to E. So this could also be GHE, but GE is going to be 110 plus 140, which is 150. GEF means I'm going from G to E to F, so that's going to be all of these. 150, because that's what this one was, plus that 80 is going to be 230. GF is going to be the shortest distance from G to F, so that's this angle here. GF, let's see, this was 230, so we're subtracting the 360 minus the 230, and you get 130 for GF. FHE is going to be everything except this 80 degrees, so you could say 360 minus 80, or you could add up other ways and you get 280. Tell whether the arcs are congruent. So when it says the arcs are congruent, then that means the arc length. Arc length, not the arc angle measure, okay? So arc length, are the arcs are congruent? These are congruent because they are in the same circle and they have the same angle measure. So yes, they are from congruent circles, you can say, and congruent angles. This one, even though they are congruent angles, these are circles of different radius, so that means the circles are not congruent. So because no, the circles are not congruent. So the length or the distance from A to B and from C to D are not congruent. The next one. When we have segments or chords like this in a circle that are congruent, then they have the same angle measure here. So that means that this arc and that arc are congruent, this angle and this angle are congruent. So you can set those equal to each other. We know that those chords are congruent because of the notches there, they're marked congruent. So you have 2x equals x plus 40. Subtract x from both sides, x equals 40. It wants us to find the measure of arc AD. So that means we're plugging in 40 for x. So we have 40 plus 40, which is 80 degrees. This one, same situation, chords are congruent, so their angles are congruent. So to find the measure of arc AD, I need to find x first. So x plus 16 has to be equal to 5x. Subtract x. 16 equals 4x. Divide both sides by 4. X equals 4. Now it wants us to find the measure of arc AD. So I'm plugging in 4 for x. So 4 plus 16 is 20 degrees. On the back, it says use the diagram of circle D. If the measure of arc, so this is another way of saying arc AB. Arc AB is 110 degrees. Find the measure of arc BC. So it tells us that these are congruent. So that means that their arcs are congruent. So if AB is 110, then BC must also be 110. Because it gives us these measures are both 9. If it says AC is 150, then find the measure of arc AB. So if AC, that's this arc here, is 150. Again, these guys are congruent, so we could say X and X. Okay, so because they're congruent, we can give them the same variable. We have AC, which is 150, plus the X, plus the other X, because the whole circle has to equal 360. So you can say 150 plus 2x equals 360. Subtract your 150 from both sides. And you get 2x equals 210. Divide both sides by 2. You get x equals 105. X is arc AB, so that is 105 degrees. Now, 2 chords are congruent here, then that means the segment from the center to the chord, so like the radius there, is also congruent. So that makes this congruent to that. So QR equals ST equals 16. They're both congruent. Find CU. So we want to find this measure. Well, first I need to find the value of x because CU is 2x. So because the CU and the CV are congruent, because the chords are congruent, then I set those two equal to each other. 2x equals 6x. Oops, sorry, that's a 5x. 5x minus 9. So I'm going to subtract my 5x from both sides. Negative 3x equals negative 9. Divide both sides by negative 3. X equals 3. It didn't ask me for the value of x, it asked me for CU, so I'm going to plug that in. So CU equals 2 times x, or 6. The measure of the indicated arc in the diagram, so that's what we're trying to find here. So anytime a chord goes through a diameter here and it's a right angle like that, then these guys are congruent, making these two things congruent. So if our angles here are congruent, then our arcs are congruent, so I can set those equal to each other. 9x equals 80 minus x. Add your x to both sides. 10x equals 80. Divide both sides by 10. X equals 8. So if x is 8, I can use that to find these arc measurements. So arc CD, we have 9 times 8, which is 72. DE, we have 80 minus x, so 80 minus x, which is 72. And then CE is going to be the rest of the circle. So 360 minus 72 gives us 144. A few more here. And we're going to use some right triangle situations to solve these. So this one, we are given that this is a right angle, so that must also be a right angle. This is a diameter, so from here to here is half of that, or the radius. And because this is perpendicular here, this cuts it into two congruent pieces. So to find the value of x, I'm solving this triangle. I have a right angle, I have 8. So a squared plus b squared equals c squared. X squared plus 8 squared equals 10 squared. 8 squared plus 64 equals 100. Subtract 64, x squared equals 36. We're talking about a measurement, so when we take the square root, you're only going to take the positive. Can't have a negative segment length. Number 12, same situation. This is a radius. It doesn't matter where the radius is on the circle, as long as it's from the center to a point on the outside of the circle. That's also going to be x. Because of this perpendicular line here, it cuts it into different pieces. So we have 4 there. So we have the same situation. A squared 4 plus b squared 3.6 right? Equals hypotenuse squared, which is x squared. You get 28.96 equals x squared, or x equals 5.4. 14 is the same as 12. Just moving our radius, it's going to be the same length because we know it's from the center to a point on the circle, which is the definition of a radius. This again is half of 22, so that's 11. We have 11 squared plus 6 squared equals x squared. 121 plus 36 equals x squared. 157 equals x squared. X equals 12.5. And you take the square root. 15, same situation. We have a leg here, so we're going to have x squared plus 15 squared equals 18 squared. X squared plus 225 equals 324. Subtract your 225, you get x squared equals 99. Take the square root and round, you get 9.9. The next one. So this time we want to find this whole length. We're given that this is 5 and that this is congruent to that. This piece is 7, so that makes this piece 7. So what I'm going to do here is find my radius. And then I'm going to use that radius to find half of this segment and then double it to find the whole thing. So 7 times 2 is 14 there. So if I find 5 and 7, I'm going to use that to find this value. I'm going to call it A, right? But because this is also 5, this is also 7 because they share the same hypotenuse there. So that makes that 7 and that 7. So there we don't even have to do the Pythagorean theorem. You could go through and do that. You don't have to do that. These are congruent. So 7 plus 7 or 7 times 2 is 14. Here we have congruent chords. This is 2.5, this is 2.5. Add them together, that's 5. So their distance to the center is going to be the same. So we have 2 here, so that x also has to be 2. Over here, because the distance from the center to the chord is equal, the perpendicular distance there, then that means the chords are equal. So if this is 25 and that's congruent to that, that's also 25, which makes that whole chord x, or 50, twice that. And then here again, these are all marked congruent. So because these are congruent chords, they're equidistant from the chord to the center of the circle. So that is going to be 8. If you have questions, please let me know. I'm happy to do a Google Meet. Have a great day.